On August 17th, I drove out to the site of the infamous 11foot8 bridge, which is now 12 foot 4 inches, and 3D scanned the area. My goal was to test out a new method I had put together for meshing point clouds from 3D scanner data, but I also thought it would be beneficial for fans of the bridge to get a better picture of how the warnings work leading up to the bridge. I'll also measure the clearances, not only of the crash beam and bridge, but also the warning sensor. Last, we'll reconstruct how the system works with a quick animation. I will also have this mesh available on Gumroad if you want to play around with it yourself. For those that don't know, this is the infamous 11foot8 bridge. Over the years, this bridge has administered a ton of damage to unsuspecting overheight vehicles, and all the carnage is captured by Yovo68 on YouTube. Make sure to search for his videos. And you can't really blame it on the traffic engineers. There are numerous signs leading up to the bridge. Then there is a sensor that not only illuminates a big box sign that literally says, "Overheight vehicle must turn," it also triggers the traffic signal to cycle red, giving the driver more time to consider their next move. Alas, they still hit the bridge, some of them plowing through the red light, eliminating any empathy we might have. In response, almost 2 years ago, they raised the height by 8 inches to 12 foot 4 inches, and, well, the crashes kept coming. On the day I was out there, I brought my 3D scanner and did 17 scans of the scene in about 2.5 hours. The scanner is a Faro X130, and I did the scans at 1/5 resolution, 3x quality, and with color. It is called an X130 because the maximum distance it can capture is about 130 meters or 400 feet. While I was out there, I did see 2 overheight vehicles trigger the sensor, and I recorded them nervously. While I do enjoy the clips, I would have felt bad had I witnessed a crash in person. The first one was this large box truck. Next was this tractor trailer, which I later saw wandering around trying to find another route. Recording them allowed me to get footage of the timing of the sensor that I will use in the animation. Back at the office, I loaded up the scans with the software that comes with the scanner, registered or aligned the scans, applied the color, then exported them as individual E57 files with color and gray so I could process them into a mesh. The mesh procedure is a process I wrote in Python using the libraries of pymeshlab and pandas to clean, mesh, and texture the data. I call this version 2. It is an evolution of a process I've been using for a few years now. However, the new version is quicker, more reliable, gets better data, and is easier to run. I first load all the completed meshes in Rhino 3D, and we can see how the mesh turned out. Everything looks really good. All the objects have good detail, but there is a lot of junk data, such as those from passing cars, pedestrians, and reflective signs, which is easily removed in Rhino. After finishing that, I export it as an FBX and import it into Blender. In Blender, I use texture painting to remove some of the vehicles that got projected onto the road. With the scene cleaned up, I then put together this quick animation to show how the system works. Here we have an overheight truck. A few seconds in, it triggers the overheight sensor, which immediately turns on the warning sign. About a second later, the light turns yellow. Then, close to 3 seconds later, the traffic light turns red. The truck is going at a constant 35 miles per hour. The timing of this is based on a video I took at the site. So let's answer some questions you may have. What is the actual clearance? Is it exactly 12 feet 4 inches? How much does it vary relative to the crown in the road? Is the crash bar lower than the bridge? How conservative is the sensor? For that, I go back to Rhino and first extract the crash beam, then draw a line along the lower edge, and last project it down vertically along the road. Measuring between these two lines gives us a near exact distance between the road and the crash beam. Looks like the crash beam at its lowest point is 2 inches higher, and on the edges 8 inches higher than the stated height of 12 foot 4 inches. Repeating the same method for the bridge itself shows that on average it seems to be about 2 inches higher than the crash beam. And the sensor is pretty conservative at nearly a foot lower than the crash beam. That about wraps this project up for now. Here are a couple of other views of the animation, an in-cab view, and last, I matched the view in the YouTube videos. Maybe in the future I'll make the animation look cleaner by remodeling some parts of the scene. If you want to play around with this scene, I have the Blender and FBX file on Gumroad for $10. This does not include the animated truck since I purchased it for another project I did. However, I am including the empties that the wheels and bodies are parented to. See the link in the description. Thank you for watching. If you like this video and want to see more projects like this, make sure to give a thumbs up and subscribe.